In the last lecture, we have studied how to find the dimensions of velocity, acceleration, work, power. Now we are going to study the uses of dimensional equation. The first use of the dimensional equation is to verify the truthness of a physical equation. For that, we take the example here. The first kinematical equation of motion is as S is equal to ut plus half at square. See, in this case, S is displacement, u is initial velocity, t is time, and a is acceleration. The displacement dimensional equation of displacement is equal to L raised to 1 in square bracket, because in the displacement mass is absent as well as time is absent. Therefore, we raise the power of mass as 0 and power of time as 0. Hence, the equation of displacement becomes equal to, in square bracket, mass to the power 0, length to the power 1, time to the power 0. Similarly, this is the we can calculate for dimensional equation for u into t. So that is equal to dimension of initial velocity into dimensional equation of time. Therefore, in square bracket, L raised to 1, t raised to minus 1, in another square bracket, t raised to 1, and that is equal to m raised to 0, L raised to 1, and t raised to 0. Similarly, now we find the dimensions equation for a into t square. That is equal to dimension of acceleration multiplied by square of the dimensional equation of time. Therefore, in first square bracket, L raised to 1 into t raised to minus 2. In second square bracket, t raised to 2, and it simplifies as, in square bracket, m raised to 0, L raised to 1, and t raised to minus 2 and plus 2 becomes 0. Because in the rule of in multiplication, we take the addition of their power or indices, that is minus 2 plus 2, it becomes equal to 0. Therefore, in this way we have calculated dimension equation of S, dimensional equation of ut, and dimensional equation of at square, and half is constant, it has no dimension, and therefore we write it as, to the left hand side, mass in square bracket, mass to the power 0, length to the power 1, time to the power 0, that is equal to mass to the power 0, length to the power 1, time to the power 0, plus mass to the power 0, length to the power 1, time to the power 0. And from this we come to conclusion that the dimensions on left hand side is equal to the dimensions on right hand side, and hence the above physical equation is dimensionally correct or true. Similarly, we see now the second use of dimensional equation. Second use is to obtain the conversion factor between two units of same physical quantity in different units. Therefore, see here in this case, Newton and dyne are the units of force in MKS and in CGS systems respectively. Dimensional formula of force F is equal to, in square bracket, mass to the power 1, length to the power 1, time to the power minus 2. And we assume it here as, let x dyne is equal to 1 Newton. Here we write now x multiplied by dimensional formula of force, that is x in bracket m raised to 1, l raised to 1, t raised to minus 2, that is equal to the right hand side also we write mass to the power 1, length to the power 1, time to the power minus 2. But to the left hand side, we were going to write the CGS system, and therefore x in bracket, we measure the length in centimeter, mass in gram, and time in second. That is equal to the right hand side. Now we have to write the unit of length as meter, unit of mass as kilogram, and unit of time as second. And therefore now we can calculate the value of x. X becomes is equal to unit of length in MK system divided by unit of length in CGS system multiplied by unit of mass in MK system divided by unit of mass in CGS system multiplied, but unit of time in MK system as well as in CGS system is second. Therefore we write it as multiply by second upon second. So therefore now we write as x is equal to, see here in this case 1 meter is equal to 100 centimeter, and therefore we write it as 10 square centimeter divided by centimeter multiply by 1 kilogram is equal to 1000 gram, and therefore we write 10 raised to 3 gram divided by gram multiply by second upon second, and in this way we calculate the finally the value of x is equal to 10 raised to 5. See here in this case in multiplication we add the powers of 10 on both the terms, that is 2 plus 3 becomes 5, and hence the value of x we have calculated, that is equal to 10 raised to 5, and in the first equation we can replace the value of x as 10 raised to 5, and therefore we have derived the equation 10 raised to 5 dyne is equal to 1 Newton.